TB is a vertical pole in the ground. AC is horizontal ground. We're told the distance AB is 10 meters. So here is AC. This is horizontal ground, and the points A, B and C are all on this horizontal ground. The distance AB is 10 meters. TB is this vertical pole. Alan is at A. When he looks at the top of the pole, the angle of elevation is 55 degrees. We want to find the height of the pole. So it's this angle here that is 55 degrees. It's the angle that Alan looks up at in order to see the top of the pole. This is the height h of the pole. We can see here that we have a right-angled triangle. We know this is a right angle here because the pole is vertical and the ground horizontal. If we look at this triangle, for this angle here, 55 degrees, this is the hypotenuse, the longest side. This would be the opposite, and this is the adjacent. We want to find h, which is the opposite, and we know the adjacent. If we write down so, car, toa, for opposite and adjacent, we need toa. So working from the definition, we get that the tan of 55 degrees is equal to the opposite, which is h, divided by the adjacent, which is 10. Multiplying through by 10, h is then equal to 10 times the tangent of 55 degrees. So calculating, h is equal to 14.28 and so on. So to three significant figures, we give the answer 14.3 meters. Note that in this type of question, it's possible that we may need to use this value for h for other calculations. If we do so, we'll be inaccurate if we use the three significant figure version, especially if we give more answers to three significant figures. Therefore, we should do one of two things. Either store this value as the last answer in the calculator and use it, or keep it to an extra few significant figures and use the longer version of the number in subsequent calculations. We're now told that Charlotte is at C, which is this point here. AC is 25 meters, so this entire distance is 25 meters, and since this is 10 meters, it follows that BC is 15 meters. We want to find the angle of elevation from C to T, which means we want to find this angle just here. This is the hypotenuse for this right-angled triangle. This would be the opposite to x, and this side the adjacent. So we know the opposite as we found the value in the previous part of the question. But remember, we won't use 14.3. We'll use the last answer button on the calculator, or at least a couple of extra significant figures that we wrote down. And we also know the adjacent. writing down our mnemonic, so car toa. Here we have adjacent and opposite O and A, so once again we need toa. So working from the definition, the tangent of the angle, which I called x, is equal to the opposite, which is 14.28, and so on. Since this was the answer to the last calculation I did, my calculator has stored this as the last answer. So when I come to do this calculation, I'm just going to press that answer button to recall this value. If that's not the case, I would have written down maybe 5 significant figures and used that. Divided by the adjacent, which we know is 15. So x is going to be the inverse tan, remember that's shift tan on the calculator, of the 14.28 and so on, divided by 15. Doing the calculation then, I press shift tan, open bracket, answer divided by 15, close bracket, equals, and if you follow this calculation you should get 43.59 and so on, and therefore x is 43.6 degrees, correct to 3 significant figures.